Evening, everybody. My name is Andrew Kelly. I work for a company called Baloo, and I'm going to talk to you about constraint layout. As Georgina mentioned, what I believe to be the only layout you'll ever need after today. Forget your relative layouts; they're gone. They're not needed. Quick review of the layouts you may be using at the moment. Absolute layout. Hopefully, you're not using that because it was deprecated literally the day after it went out of the door. There's linear layout for laying out views in a sort of a vertical or a horizontal row. There's a relative layout, which lets you lay out things relative to one another, above and below, start and end. Frame layouts, which let you order views in kind of like a stack based on like a Z order, and if you don't supply a Z order, it's just the order that they're defined within the frame layout. And table layout for doing things like tables. All of them up until now have been sort of kind of okay for what you need to do for your layouts. Constraint layout is the next kind of level. It's like 10x better. Not only in terms of the things you can do with it, but in terms of performance for things like layout and measure passes. Relative layout's quite expensive when it's kind of measuring all the bits and pieces and where they need to go relative to one another. Constraint layout has new algorithms and they're improving all the time. And it's a lot more efficient in terms of rendering your views onto the screen. So, as I mentioned, constraint layout is the one you should be all using from now on. It's the default one that you'll be using in Android Studio. If you kind of go into the menu and say File, New, Layout. If you're using Android Studio 3.0, which is about to go into stable, it's just had release candidate 1 this week. It'll be the default layout that it creates. So it's probably worth getting familiar with constraint layout because it's the one you'll be using going forward. It works on API 9 and above, so hopefully that covers all the apps that you're writing, since how the support library is now only API 14 and above. So if you're writing apps that don't use the support library, congratulations, you're doing really well there. The current version of constraint layout is 1.1.0, so they're going towards the 1.1 release at the moment. And beta 3 was released literally 2 days ago, I think, or 3 days ago. So it's kind of evolving all the time, but they're getting close to their first 1.1 release. Android Studio 3.0 has an amazing kind of layout editor, if that's your thing. I prefer to use the XML kind of way of defining my views, but as you start out on your journey with constraint layout, the visual editor is a kind of a really good way of sort of getting your head around the concepts of how things relate to each other and how constraints work and what they mean when you kind of link different views together. It's based on something called the cassowary algorithm, which is the same algorithm that the iOS developers have been using for many years now in their auto layout manager. So it's got a sort of a solid background in terms of how it lays out views and stuff. So it's like a proven sort of technology. It's not just kind of freshly made up by Google. This is something that's been around for quite a while. And the reason it's quite performant when you compare it to things like relative layout is it maintains a very flat hierarchy. You don't need to nest children within children to kind of get the views that you want to create. It's all very flat, and the constraints that you define between the views give you the power to kind of create very sort of complicated layouts in a very simple way. So hopefully, is that too small to read? I apologize if it is. I wanted to get a lot of stuff on the slide. Can I make that bigger somehow? Sorry, it's probably...
Do you know how to use the accessibility thing to zoom?
I'll read it. Anyway, so there's lots of features of constraint layout. So there's 5, I think, main topics. So you've got constraints, which basically allow you to define a relationship between two views in terms of this view A is constrained to the parent in a particular fashion, or to another view, be it the start of this view is constrained to the end of that view, and they will be nicely next to each other. And you can define constraints based on the top, the bottom, the start and the end, and the baseline if it's a text view. So you can have 2 text views, the baselines will be constrained to each other, so if you move one down the screen, the other one will be aligned with it. So that's just kind of basic constraints. You can have chains, which is where 2 views will be constrained to each other. So there'll be a sort of a bi-directional relationship between the two. So you might say the end of this view is constrained to the start of that view, and the start of that view is constrained to the end of that one. So then you can define a weighting between the two, and they'll be constrained. So I've got demos, I've got some samples that show these visually in a second. We'll go through each of these separately. Guidelines is another thing that's really handy. A guideline, if you've come from a sort of a graphic design background, it's like a virtual view. It doesn't really exist in your layout when it's rendered on the screen. It doesn't have a visual component to it, but it's useful to have a guideline. You might have one that's sort of 16 dp or 72 dp, one of the kind of the key lines of a material design layout, and you can then constrain your views to match up to that key line perfectly. So you can set up these kind of constants that are useful. You can have one at 50% if you want to lay out something that's in the middle of the screen and lay out things just either side of that. So these guidelines can be vertical or horizontal, and you can position them based on a absolute sort of dp value or based on a percentage of the parent that it's in. You can have another thing called a barrier. A barrier is really handy. It gives you something similar to a constraint, to a guideline, but it's constrained by more than one view. So you might have some text views laid out vertically, and they could change in width. So you might have some titles that are brought down from a CMS, and you don't know necessarily at runtime which one of those views is going to be the widest. And you might have some other content which you want to make sure never overlaps those 4 views. So you can have a barrier that says, okay, always be on the outside of those 4 views, and it doesn't matter which of those 4 views is the widest, the barrier will move to be at the widest point. So as they change in size, that barrier always moves, and then you can constrain other views on the other side of the barrier. So a good example would be if you change from sort of English to German. Some words get really short in German and really long. If you've got language changes, you don't want to constrain just to one view. You want to make sure that all the views don't overlap. And I've got a slide that shows that later on as well. And finally, that you can have a concept of groups. So you might have a group in a layout at the moment where you have like a child nested within like a linear layout or a relative layout, and you can apply visibility to that layout, and all the children will disappear when you change that. A group on constraint layout, again, is a sort of a virtual object. You don't have to wrap the group around the children that you want to reference. You can just reference them by the IDs of those views, which means, again, you maintain a very nice flat hierarchy, which is great, and we'll come to why that's great later on. But also, the views don't have to be next to each other. They can be higgledy-piggledy all around the screen, and you can change the visibility and say, okay, when this condition is true, make this group invisible, and all the views that are referenced by that group will disappear. So that's quite handy. Excuse me. So hopefully this is easier to read. So going through those ones that we just mentioned, the sort of the 5 different groups, this is constraints. So as I mentioned before, you can constrain views based on the top and the bottom and the baseline, which is the first kind of image there, or the start and the end. So you can anchor views in the visual layout editor by dragging a little squiggly line from one edge to the other, and it will draw the constraint. In the second image down here, you can see that we've constrained a view to the parent. So you can always drag a constraint to the edge of the screen, and that says basically, okay, everything has to be laid out relative to the edge of the parent. And in this case here, if you have a constraint on the start and you have a constraint on the end, the default position then will be to have that constraint, that view centered in the screen. And you can apply a bias if you wanted to. So in the third example here, we've got a view that is constrained to the start and the end of the parent, but we've set the bias towards the left-hand side. So you can say, actually, don't put yourself equal distance from the edges. Move yourself towards the left-hand side. And you can specify that as a sort of a percentage from a value from 0 to 1, I believe. So you can lay out things relative that way. A new one that was released in beta 3 just this week, or Friday I think it was, is circular constraints. So you can have 2 views constrained to each other, and it takes the center point. So this is a new thing that they've only just released, where you can constrain things to the center, and you can have one view laid out relative to another view based on an angle and a radius. So you can have, as in the sort of the second example here, 2 views laid out, and you can do some cool animation stuff later on, where if you change the angle or if you animate the angle, you can make views rotate around each other, which is kind of funky. And that's kind of a new one in beta 3. So I mentioned chains. Chains are kind of handy for defining relationships between multiple rows. So you can see here in the first image the bidirectional relationships between the three views, A, B, and C in the middle there. They've got the bidirectional constraints. And you define how those three views that make up the chain are spaced out or laid out on the screen by setting the type of chain on the head element. So one of those, the first one in the list there is the head element of the chain, and you can set the type to be one of the five that are listed underneath. So spread chain means take all the spacings between them and evenly distribute those equally. You can have a spread inside, which basically says take the end, the head and the tail of the chain and stick them next to the parent and take all the remaining space and then equally distribute that between the remaining elements of the chain. You can have a weighted chain where, a bit like a linear layout, where you can specify a weighting to say this view is 2/3 of the width and this one is only 1/3. You can specify a weight on the chain, so you can see here on the third row down, the A, B and C, they fill the width of the parent, and B and C are slightly wider because they've got a larger weighted value. You can pack the chain together, so you can say, look, I don't want any spacing in between the elements, I want them all bunched up next to each other. And again, you can specify a bias with that. So in the last row there, you can see we've got a packed chain with a bias that moves them kind of over to the left-hand side there. And you can have vertical chains as well. You can have vertical and horizontal chains at the same time on the same widgets, and that's when your mind kind of goes, oh my God, and kind of explodes. So yes, that's chains. Guidelines, hopefully this image is probably a bad screen grab. Again, so you can see the virtual guideline there in the middle, kind of the dotted line going top to bottom. It's set as a percentage layout, which is why they've got the percent screen symbol at the top there. And we've got a view, the text view, which is laid out again against the guideline there. This is kind of a snapshot from the blueprint editor. So in the Android Studio, when you're laying out your guidelines and your views, you can go into blueprint mode and you get the kind of the old sort of technical drawing style blue background with the white dotted lines to show your views and the connections between them. And this is kind of what you'll see, and hopefully if you've got time, we'll see a little bit of this in Android Studio later on. And again, as I mentioned, they can be specified on an absolute kind of DP value or based on a percentage. Again, here with the barriers, as we talked about earlier, so we've got two text views on the left-hand side. One is warehouse, and one is the word hospital, and some random text on the right-hand side there that's constrained to those two. The barrier, again, is the vertical dotted line, as we can see. Now, if we were to change the language of this particular example, the word warehouse in German is quite short. The word hospital in German is quite long. But what would happen is the barrier would still be on the right-hand side of both of those text views, so your main content here on the right-hand side would never overlap one of those views. So previously, if you just tried to do that with constraints, you wouldn't have been able to have multiple constraints working together to constrain that one. So one of them would have extended over the top, and you would have had some text on top of text, which is not what you want. Again, as we discussed, groups, there are virtual objects. It means you can have a flat hierarchy. The only thing you can change about a group at the moment is its visibility. I expect that to change over time to allow you to change other things on a particular group. But at the moment, you basically say, here are 5 views that I want to treat the same, and you can set the visibility on on the group, and they all disappear. It's kind of handy. So if you've ever had to do that in code to say, look, these 5 things on a form disappear when you click a button, you have to go through and reference each of them and get rid of them. This is a lot easier. I know Butterknife, if you've used that library, has a grouping concept, but this is quite nice as well. One of the other things that you can do with views in Constraint-Layout is aspect ratio. So previously you might have had to create your own relative layout or a linear layout or a frame layout that has a specific bit of code in the on measure that says, okay, if my width is so much, make my height a proportion of that. So you have like a 16:9 relative layout that you use for laying out images, so that they're all in the correct aspect ratio for whatever app you're building. We've all probably written one of those. Google, after having seen so many implementations of one of those, actually came out with a thing called percentage layout, which I don't think anybody uses because it was kind of like released and then kind of nobody talked about it. So constraint layout, you can maybe see here there's a highlighted line When you specify a view, you can also specify a dimension ratio. So you can say, look, I want the height of this one constrained to the width, or you can say I want the width constrained to the height, and then you give it a ratio in the text there. In this case, it's 16 by 9, so you can have like a widescreen view. So you don't need to create a custom view for this kind of stuff. It's just, here's a line of code, make it so that this view maintains the aspect ratio. And you can set that in code as well, so that's kind of cool. So animations, hopefully these will play. I don't know if I have to click on, yes, there we go. So one of the things that you can kind of do now is I've always found it very hard doing animations on Android. It's very tricky to kind of lay things out, especially if you've got a deeply nested hierarchy. The widget that you want to move might be 3 levels down, and you might want to swish it around to move it over here. And you've got to move a whole lot of other bits and pieces to do that, so it's quite hard. With constraint layout, because everything is very flat, you may even just have constraint layout as your top and bottom layout, and everything else is a single child level down of that parent. You can move things around independently of each other, and you're not having to make all these massive kind of redraw, relayout calls, because you're not recalculating the depth of that hierarchy again and again and again as you move objects around. So you can do kind of little animations where things appear and things move out of the way, which is the example of the form in the middle. And the little weather example here at the bottom is, you click on a button and we take the row of weather summary at the bottom and turn it into a weather details, and we just swish things around and move them to the side. Now these animations may or may not look particularly exciting, or they may look astoundingly amazing based on what you've used before, but the actual mechanics to building these is very, very simple. And hopefully if we've got time, we'll show you this in Android Studio. But essentially what you define is the starting position. So you might have 2 XML files per screen. You might have the starting position where all the widgets are laid out at the beginning. You might have an end position, a bit like keyframes in an animation, where you say this is where I want them to be at the end of the animation. And using 3 or 4 lines of code with the transition manager framework, you can say make this one look like that one, and it will move all the components around for you. And you can specify things like the delay and how long it takes for them to animate. You can specify interpolators, whether they move in a linear fashion, or whether they accelerate and decelerate, or whether they bounce if you want to go crazy, and stuff like that. So it's really kind of a powerful animation framework. So here's a kind of an example I knocked together when they released the Beta 3 the other day with the circular properties, where you can kind of animate views going round and round in circles. You have to forgive the crudeness of the images. I just grabbed them from some stock imagery stuff online. So we've got 3 planets orbiting the sun there, and we've changed the speed of the animation to go round and round and round. So that's one layout with some animation attached to it. The final view, where you can see the details of the planets when you click on the sun, is a second XML file. And the cool thing about the way the animation framework works at this point, it doesn't matter where you click, or it doesn't matter when you start the transition, where those orbiting planets might be. That is the set of constraints that will be fed into the transition framework. So if the Earth is on the top left corner at one time, it'll move a little bit of the way into its final position. If the Earth is at the far bottom corner, it'll just move a bit further when you run the animation the second time. So you don't have to worry about doing the maths, working out the speed of the animations and all this kind of stuff. It just does it for you. And you can do it in kind of a very natural way. And yeah, it's quite simple to set up. So some final thoughts on this. So yes, you can use the visual editor to lay out all your components, and it might be a great way to start playing around with constraint layout if you haven't used it before. Once you get your head around it, I think it's actually faster to just go in there. Once you know the names of the constraints that you're applying to a particular view, it's quite easy to just kind of shortcut them on the keyboard in the XML layout and put them together in your mind that way. You can actually have the XML layout in Android Studio shown on the screen, and you can have the preview of that shown side by side. So as you're editing the XML, you can actually sort of do a visual check what it's going to look like at the end, which is quite handy. One of the gotchas that you might see is that the editor itself, when you first drag widgets from the kind of the palette onto your layout for positioning, they have no constraints yet. So in order for the IDE to not just kind of put them all at the top left-hand corner and stacked on top of each other. It gives them a editor layout. So you'll see these kind of editor underscore layouts, which are absolute positions within the IDE, and they're only used by the IDE. So you can, imagine that you can then sort of drag them around a little bit and draw your constraints where you want them to go. If you forget that that's actually happened and you try and run your app at that point, everything will be sort of top left-hand corner, because those are only used by the editor to kind of help you whilst you're dragging the constraints around, and they're not actually used at runtime. So you might look at the editor and go, brilliant, that's exactly how I want it to look. And you've dragged it around, but you've not actually defined any of the constraints that hold those views in place. And as soon as you run it, it's a blank screen. You're going, what's going on? So yeah, so just be careful. You get a little red triangle, I believe, next to the widgets that haven't had any constraints defined. So if there's any ones with red triangles, you'll probably notice that they're not being positioned as you expect in the final one. As I mentioned, you can use the side-by-side view for XML if you like that. And one other thing, you may have used the match parent when you're defining a width or a height previously on a relative layout or a linear layout. You might have said match parent to make that particular layout the full width of its parent. They don't really have a concept of that anymore in constraint layout, so the equivalent is something called match constraints. Now, there isn't a keyword for match constraints in the same way you have wrap content and match parent, so you have to specify 0dp, which is something you may have used before when you want to do like a linear layout and say, hey, look, just be as wide as you want to be. In this case, the 0dp says be as wide as you want to be, but you're now constrained by the constraints that you've defined earlier on. So yeah, match parent, don't use that on your views, use 0dp instead, which is now called match constraints. If you see that written down anywhere, just think 0dp in your head. Again, these slides are going to be on the Meetup website, so if you can't read it now, don't worry about it. I know the text is probably a little small, I apologize for that. So there's 3 bits of official documentation for constraint layout. There's a training course, there's the actual documentation for constraint layout itself, which has got some examples in there, which is where some of the graphics have come from for this particular slide. There's some other resources out there that have been done by the community. ConstraintLayout.com is quite a good one. There's some sort of best practices, use cases. If you're thinking, how do I do that in constraint layout? ConstraintLayout.com has probably got an example on how to do that, and it's kind of growing all the time. There's a guy called Mark Allison who does a Styling Android blog, and he's done a whole series of blog posts about constraint layout, taking you from the very sort of early stages when it was beta 1 kind of stuff, and sort of going through all the new features as they've been added. So that's a good series. There's a lady called Rebecca Franks. She's an Android GDE based in South Africa. She's done a video recently called Mastering Constraint Layout, which is kind of a similar talk to this one, and she actually goes more into Android Studio. It gives you the visual thing, and hopefully we'll do a couple of minutes of that. And I wrote a little blog post as well about how to do the circular constraints, which was released this week. So if you want to do a clock or orbiting planets, I can't think of any other use cases, but yeah, you can use that as well.